Good evening, everybody, and I want to wish you happy Eid. Today I'm still gonna continue with calculus, and before then, this is still GMO. She used to know. So today's topic is rate of change. Rates of change. A rate of change is one of the application of calculus. As I have been doing in my lecture, I always mention this dy dx. For the sake of today's lecture, I would like to define dy dx as the rate of change of y with respect to x. At the level of jump, once the word rate is mentioned, we expect to see time. For that reason, I will give another definition of this dy dt. dy dt can be defined as the rate of change of y with respect to time t. So we're going to be using this definition often. So rate of change, as far as GEM is concerned, will involve the use of the following formulae. I just want you to take a good note of them. If you have a question that involves the rate of change of area with respect to its radius, this is the appropriate formula to use. dA dt is equals to dA dr times dr dt. It is just similar to chain rule or the composite function that I have treated before in one of my previous videos. So the second formula is, if you have a question that's link volume and radius, the formula you're gonna use is this: dv dt is equals to dv dr times dr dt. Sometimes you can also have question that will involve the volume and the height, and if that happens, the formula you're gonna use is dv dt times dv dt equals dv dh times dh dt. Let's get down to business. We're gonna use this formula to solve some questions. So I would like to start with example 1. Example 1 was taken from UME, which is now UTME, of 2000, question 38. The question goes thus: if the volume of a hemisphere is increasing at a steady rate of 18 pi meter cube per second, at what rate is its radius changing when t is 6 meter? This is the question. So I want us to take note of those words I've underlined: volume, hemisphere, rates, then radius. So the first thing that I always advise students to do here is to first of all bring out the data that you have in the question. So just take a look at this. From the question, let's go back to the question and see. If the volume of a hemisphere is increasing at a steady rate of this, you see, volume then rate, it means dv dt, then of, it means we have been given dv dt to be equals to 18 pi meter cube per second. So let's continue. At what rate, you see, this is a question, at what rate is its radius changing? It means this time the question is asking us about dr dt. So that is why here I have written that dr dt is equals to question mark, what we don't know. And again, the question says its radius is 6 meter, so that's why I put here r equals 6 meter. So if you go by the formulae I have written, you discover that the appropriate formula is dv dt equals dv dr times dr dt. So dv dt we know it, so I marked it. dv dr we don't know, and dr dt we don't know. So we need to know one of them before we can solve the other one. So dv dr we can solve it by establishing a relationship between v and r, the volume and the radius. Remember, what we used to know is volume of a sphere. Now volume of a sphere is 4/3 by r cube, right? But you need to be careful here. The question is talking about a volume of hemisphere, so the volume you're gonna use is that of hemisphere. So now I have volume of hemisphere equals 2/3 by r cube. Is just half of this, as if I'm multiplying this by half. So from this formula, this expression, I can have dv dr is equals to, I'm just gonna multiply this 3 by 2/3 as I did here. Pi still remain the same, it's a constant, and r will be, I'm gonna take 1 away from this 3, so 3 minus 1, so 3 cancels 3, I have 2 pi r squared. Okay, so now I have this dv dr. So the next thing is what? To substitute. I have this, so I can get this. So now this is done in the next page. So you have 18 pi 2 pi r squared times dr dt. So what you just need to do here is to make dr dt the subject of the formula, and so you have 18 pi over 2 pi r squared. So you have 9 here, 2 here, 1 2 in 18, 9. Pi cancels pi, so you're gonna have 9 over r squared. But already in the question we've been given that r equals 6, so we can substitute straight ahead for r. So the r dt is gonna be 9 over 6 squared, and you're gonna have 9 over 36, okay, and there will be 1/4, which is 0.25 meter per second. So this is all about example 1. It's a bit long, but it's interesting. If you know it, it won't be as lengthy as this. So let's look at example 2, UTME 2013, paper type U, question 37. So let's look at it. The radius of a circle is increasing at a at the rate of 0.025 centimeter per second. Find the rate at which the area is increasing when the radius of the circle is 7 centimeter. So as usual, just bring out the data. Okay, so what do we have here? We are told that the radius of a circle is increasing at the rate, so the dt has been given. That's the meaning. Find the rate at which the area, so the a dt is what we are looking for, and already we have also been given the radius of the circle. So you bring out all the data. The r dt given, the a dt is what you're looking for, and r is also given. So what next? You go and check which of the formulae you're gonna use, and this is the most appropriate one. The a dt is what we're looking for. The a dr, we have it. The r dt, we have it. The a dr, we're gonna get it from the formula that relates a and r for a circle. Take note of that. For a circle, this question can be repeated, and instead of telling you it's a circle, they're gonna give you a semicircle. You should know how to handle that. So the area of a circle is pi r squared, right? So from here, dA dr is 2 pi r. Remember, 2 times pi, 2 pi, then 2 minus 1. You're gonna have this one, but our r is 7, so we can substitute for r here, and that will be 2 pi times 7, and that will be 14 pi. Now once you get that, you can now just go straight ahead and substitute into the formula. We have 14 pi and we have 0.025, so our final answer is 0.35. So this continues. Example 3. Now if you look at this example 3 is very simple, but you need to be very careful, otherwise you may miss it. It's from 2001 and question 36. Find the rate of change of volume V of a sphere with respect to its radius r when r is equals to 1. Just take a look at this. Very simple. See, the data we have is dv dr. We don't know, and we are given that r is equals to 1. So from there we find the relationship between v and r, which is given as this is a sphere. So we differentiate the v dr. Okay, differentiation is no problem to my audience. So our final answer is gonna be, our answer after differentiation is 4 pi r squared, but r is equals to 1 from the question. Therefore dv dr equals 4 pi, we substitute for r, okay, 1 squared. So 1 squared is 1, so our answer is 4 pi. So your answer is 4 pi cubic units. Okay, so that is that. Now this the exercise we want you to try. Okay, so question 1 and the answers are there, and this is question 2. The answer is also there. So you try your hands on this one, and I'm sure you're gonna get them. So we're gonna meet in the next class, where I will go to another topic on calculus. Before then, I say have a good night, and don't forget my salamit. Okay, send it by DHL. I will expect it. Thank you. Bye bye.